let's get started. What was the design pattern that we were doing yesterday? Where did we end? In the chart.
Command pattern.
Command pattern.
Command design pattern.
Yep. Okay, give me 1 second. Okay. So we were doing command design pattern yesterday. I told you a bit about it. Why do we use command? What is the purpose of using command design pattern? In the chat, you can tell me. Why do we use command design pattern? Whenever we want to keep a request as an object, please start command pattern from the beginning. Yes, I will. It was not clear completely. Undo, redo, encapsulating commands as object. Okay. So basically, let me give you the example again. Let's start from the complete beginning. Let's say you're designing an editor. Okay, an editor like say Lucid Chart itself, or say you're designing something like VS Code, or say Notepad. Okay. Simplest one is Notepad, right? So in Notepad, there are a lot of shortcuts and a lot of menu options, right? So in a menu option, you can do something like save, you can do something like open, you can do probably paste, copy. There are a lot of commands that you can do, right? So now these are the commands that you're doing. Suppose I copy, I paste, then I do something else. Suppose I cut, I do something else, I do something else. Now I also want to implement undo and redo. So how do I do that? That is my number one question. So one thing is, yes, so you can have a stack. I can see some people telling in the stack, you can have a stack, but stack of what? Basically, you want to undo what? Whatever was the last request that came, right? Whatever you want to undo or redo. So my question is that you want to undo or redo, what do? You basically undo a particular command or redo a particular command or a request, right? And you are doing what? You are changing the behavior on the run, right? You're changing the behavior. Does this much make sense? Yes. That when we do undo, redo, we go back one command or we go back one request. When we do redo, we apply that command again, correct? And there are a lot of times when we would want to send this command, say as a request or a request as an object in another class. Like for example, I want to send it in a parameter, like there's a function call, and I want to send that this is the command that I have been given and you take care of it accordingly. I would want to send my command or request in the parameter. So what are the problems that I'm trying to solve? Firstly, what I'm trying to do is that I'm trying to encapsulate the command or request as an object. That is the first thing that I'm trying to do. Okay. Second thing that I'm trying to do is that I should be able to send the command or the request as a parameter. It is okay if it is not clear for now. We will see a lot of code. We'll see a lot of examples. It will get clearer, right? Also, we want to decouple. What do we want to decouple? As you must have understood from now, by now, that in observer also we were trying to decouple the subject and the observers. Here also we are trying to decouple. But who are we trying to decouple? The sender of the request and the receiver of the request. Basically, the point is whoever is giving us the command, like for example, our menu option is there, right? So command is there, but we do not know how is it happening, who is actually doing it, right? The sender and the receiver. So let's try to see in terms of UML diagram, how is it going to look? I had told you a few things yesterday. It is fine. I'm going to repeat the entire thing. So basically, the point is that I'm going to have a command. Okay, and there can be types of commands. So obviously, as you must have guessed, this is going to be an interface and there are going to be types of commands. They are doing what? They are implementing. Now, by now, you must be very familiar with this, that when there's an interface, you are implementing. These are what? These are concrete commands. What can be concrete commands? Like for example, action save command, or say action open command, and so on and so forth, like action copy command, action paste command, correct? Everyone is clear till here? Everyone is clear till here? Yes or no? Yes? Anyone who has doubt till here can say no. Everyone understands what are we trying to do? Shobit is saying no. What is the problem? Swati is saying no. Okay, I can see some people saying no. Give me 1 sec. Sorry. So for those who are saying no, let me repeat that. See, we have a lot of requests coming in. Now, the thing that I'm trying to solve is that maybe I want to do undo, and then redo. I basically want to treat a particular request or a particular command as an object. Okay, you think of it like you press save or you press open or you press copy. You have sent a command, but I want you to treat it like an object somewhere in the code, right? How are you going to treat it in the code? A command came that, okay, there is a save or there is open or there is copy. How does it look like? It is not always going to be a function call, right? Sometimes I might want to store these commands. I might want to store that what all request came. Like, how are you going to store it? For example, I want to see that what all actions did the user take. Like suppose user opened, then user say copied, pasted, and then suppose did save, did close. So there are a bunch of things that my user is doing. I want to store all of this in one place, and I want to be able to support what I want to be able to support undo, redo, and maybe I want to do something. I want to use this request somewhere else. That this request has come. Now, based on this, you can do some particular information. Yes, so it is like stack storing command objects, not just stack. You just want to store it somehow. The point is that you want to have your command or whatever request came, you want to store it as an object. Does this make sense? You might want to log the commands. Yes, the objects. Now, does it make sense? Anyone is still confused? When you see it being used, it will get clearer. How are we encapsulating the command as an object? We will show this. That is what we are trying to do. Basically, there is a command. Now, this part, do you understand? There is one command and then there are types of commands, right? There is action, there is open. This much everyone has understood. This much everyone has understood. Yes, there is a command. There is action command. There is open command. Okay. Now, these commands obviously need to be executed, right? When I receive a command, I have to execute that command. Correct? Everyone agrees with this much. So now when there is a command, there is going to be an execute function. Now, obviously, this is an interface, as I had said earlier. So this is what? This is an abstract method. So obviously, these action save command and action open command will have to do what? They will have to implement the execute method. Does this make sense? That every command is going to have an execute method. That either it is going to save or it is going to open or is it going to close or is it going to copy, is it going to paste, whatever the hell it is going to do. Make sense? This much everyone has understood? Yes? Still any questions right now till this much? Okay. Now, who is basically generating this command? Let's take the example of that document itself. Who is generating the command? Like press, right? So say there is menu options. And how do I generate this command? I have, say, a function called open on click, something like this. And from there, I'm going to say command dot something execute. So I will have a command, right? So this menu option, I am going to call it what? I am going to call it an invoker of the command. And I am going to store command inside this. So there is probably going to be like this. So there is going to be, say, save command. And there is going to be an open command. What does this minus mean, guys? What does this minus mean? Private. Very good. What does the plus mean? Public. Very good. So when I do this, basically I will have to write the type. Action save command, open save, action open command. And technically it should be like this. And all the functions will come in the third block. All the members will come in the second block. Remember, UML. Okay. So now my menu options has the command. What sort of relationship is this? So my invoker has command. What relationship is this? Invoker has command. aggregation, very good, has a relationship, right? So this has commands, and but it is, the command can exist outside also. It is not like I'm creating the command inside, right? So has a relationship, aggregation. This much makes sense. So there is so what all we have discussed till now, there is an interface command, there are concrete commands, there is an invoker who's going to invoke the command. Make sense? Now we have to execute this also. We said that, okay, there is an execute function inside these. Now there are two ways that you can go about it. One thing is that you execute inside only, like over here. But now the thing is that sometimes I might want to, do the same actions on different things. Like for example, right now I am saving and opening my text document. Tomorrow I might want to save and open, say, a photo. And I want to use the for both, I want to use the same system, right? So either I can do the execute over here only, or I can add another receiver where I'm going to say that do the actual work. Like there is going to be command, like in this, when there is execute method, either I can write the execute code inside this itself, inside the command itself, or I can keep a separate receiver. In our case, say it will be a document, a text document, notepad, which will actually do the work, like open or save or copy, right? All of those actual things, it will be the one that will be responsible of doing that. Make sense? Yes? Yes, no? I will show you the code also, it will be clearer. I will show you the code, relax. Okay? And so basically, how is it going to look? Let's look at, what is our client going to do? Can I show you the code first? Then let's come back and let's see that who is doing what. Please repeat receiver. I am repeating receiver. See, when my command is there, command is being asked to execute. Now you have to either execute a save or execute an open. You have to execute something. Either we can save that document over there itself. We can write the code that, okay, file.save, file.open. Or I am saying that, they can, like, I might want to use my system for different receiver. What is receiver? It can be either, say, a photo, a text document. It could be something graphical or lucid chart. Basically, maybe I want to use the same menu options for other things, right? In that case, I might have a receiver that, okay, do this for this document. For those, I can see some confusion happening over here. Let me tell you one very good use case of why you would want to store commands. For example, in any text editor that you use, VS Code or IntelliSense or any code editor that you use, you might have seen a lot of shortcuts, right? And you can actually configure the shortcuts, correct? Like for example, right now there is a save button and you click it, and what happens from Control plus S is the same thing. Now tomorrow, if I want to, I can configure and I might say that now Control plus O should save, but Control plus S should open. Now I'm telling you that you should be able to support all of this. How are you going to do it? So suppose I have a command inside my document. All I have to do is whatever command was associated with Control S, right? Whatever command was there, like execute, I am now going to associate it to Control O. Like from Control S, I will shift it to Control O. So now tomorrow, if I want to change my shortcuts, if I want different buttons doing the same thing or different shortcuts doing the same thing, I basically have a command. But see, I can add new menu options and I can associate with them with the command. Correct? I can add more commands. OCP, remember? We can add more commands seamlessly without changing the existing code. Right now, there is save, there is open, there is copy paste. Suppose I want to have new, suppose there was no cut. Now I want to add a cut. I can add it without making change in the present commands in the present menu options. Does this much make sense? Does this use case make sense? Making you think? Just think of this use case again. I am asking you to make a document editor or text editor. And now I am saying that I have a bunch of shortcuts, but you should be able to configure that, what shortcut is going to do what. Basically, how it is going to look is that there are going to be a bunch of commands. There is going to be save, there is going to be copy, paste, open, say highlight a text, or say save, copy, paste, what else, close, whatever it is cut. Now tomorrow, if you want to configure the shortcuts, all you have to do that this menu option is going to do this. This menu option is going to do this. You can change it on the fly. You can do that. This menu option is going to do this. Yes, delete is another command, right? You understand that see what all use cases I told you till now. Firstly, I should be able to use my command or request as an object. It should be like an entity inside my code. Secondly, I should be able to configure that, okay, now this shortcut is going to be associated with this command. When I press this command should be called. Second thing. The third thing, I am supporting undos and redos. That, okay, so suppose I have, say, bunch of 20 commands. Now I should be able to log them also. I should be able to write them out. Okay, these all commands were called. And I should be able to undo, redo. I should be able to pass that entity together to some other function. Understood the problem? Yes? Pass to the, okay, I'm just reading through the comments. Has everyone understood? We need to associate commands to each action. Yes. So basically these commands, they are going to execute, right? Which command is associated to what, we will see now. Let's look at the code and it will be clearer. Okay, let's look at the code now. Going to share my screen. Can you guys see my screen? Yes. Let's look at the document only, the document example. I have written code for 2 examples, so it will be more clearer. Don't worry. Okay. Looking at the chat as well. Okay. So here, this is the interface command, the action listener command. As you can see, all it has is an execute. So all the concrete commands, the commands that implement this listener command, this is the interface command, will have to have execute, right? Ignore this for now. Concrete command. So you see action open has an execute, right? It has an execute. Similarly, action save has an execute. So these are my concrete commands. Action save and action open are my concrete commands. In my action save, there is an execute. In my action open, there is an execute. Everyone understands this much? Yes? Okay. Now, this is my receiver. Where is the change actually happening? The document, the text document, the notepad document that is actually doing this, right? So when you say open, document opened, document saved. So here I'm actually going to do the thing. I'm actually going to open or I'm going to save. Does it make sense? Yes. So this is, you can see receiver is performing the operation. There is a command interface. Then receiver is performing the operation. Then there are concrete commands. Concrete commands are what? Action open and action save. Now you see what is actually happening in this execute. We are doing what? Doc.open. Doc is what? Receiver. Remember, I made that my command could tell the receiver that you do the action. I could either do it over here itself. Suppose I could do it over here itself. Like instead of having a document class, I could have like a file over here and I could open it. Or I could save it over here itself. But for now, I want a receiver that, okay, receiver is going to do it. For now, I'm just telling that, okay, this you need to execute. What is happening in our main? Let's see. So first I created this. This is what? Document is what? It is a receiver. It is the one who is performing the action. Right? It is performing the action. These are what? These are concrete commands. Right? These are concrete commands. So action open, action save. See, they are of the base type, action listener command. Base type, and this is the derived type. So this is the interface. This is the concrete command. Right? Action open, action save. So first thing I did, created receiver. Second thing I did, created concrete commands. Create concrete commands. And you see over here, I am associating a receiver. I am sending receiver with the command, right? So receiver with command. I'm See, in this, while creating the command, I am saying this is going to be a receiver. It can either be a document, it can be a photo, it can be anything. See, so now what am I doing is, because I'm sending a receiver, I could have sent a photo over here, or I could send a video or a graphical document or something. Basically, I am opening this, I am going to perform this action on this receiver. Receiver is the one where the action is being performed. Okay. And what is menu options? This is the invoker. This is where I am invoking it. See, I know for now it might seem like, why are we doing all of this, right? But when you actually start designing, like take this example, the document example. I give you this use case that I should be able to configure the shortcuts on run, like runtime. This is a common use case, right? That my button was doing this. Now my button will be doing something else. Internally, it is following the same command, but I want to configure it again. I want to store my commands. How am I going to do that? See, these design patterns are making our life easier. Why? Because these are very commonly occurring problem. This happens very commonly in our day-to-day life. Also in interviews, also you will see these problems happening again and again. And you already have a solution to them. These are following solid principles. And we know why. See, I can add a comment on the fly. My client will not need to know. Only when I need to use it, I can nicely use it. I can add another command. I can add another receiver. You can add a receiver, my client will not be disturbed. You can add a command, my client will not be disturbed. There's an invoker who just has to say, who doesn't care how you are doing, what you are doing. It is saying, I want to open, I want to save. This is all you do, right? As a client, when you are using text editor, like over here, if you see, if I go and press save, right? If I go and press save over here, you can see this, right? Yes. So when I go and press save, all you do is do save. You do not know what is happening over there. What action do you do? Click open, click save. So you are the invoker. No, invoker is not the client. Like for example, I made this separately. Invoker is menu option. So I have made the invoker also as different. Like you can make the client itself as invoker, but to make things very clear, I wrote it like this. Invoker can be main or client. Just like in builder design pattern, we discussed that the director can be your client itself, right? You don't need to have a civil engineer creating the house, right? Similar to that. Make sense? Okay. So is this much clear? We have a receiver who is performing the action. Then we are creating the commands, the concrete commands. We have the invoker, and then we are actually performing it. Like the invoker is invoking it, that click open, click save. So in my menu option, what is happening? See, click open means what? I have commands. Remember, invoker has commands. Invoker has commands. We talked about aggregation. Right? Now this has commands. When I do click open, I do open command dot execute or click save dot execute. Yes, aggregation. So command has receiver. Yes, command has receiver. So invoker has command. And if you go inside this, inside this, there is a receiver. Document is what? It is the receiver. So let's see it again. So invoker has command. Command has receiver. Receiver is the one who is actually performing the action. Let's run it also and let's see. It will get clearer. It is fine, guys. We take time to understand this. As long as you understand what problem we are trying to solve, how are we designing it, even at the upper level, when you start coding, when you start drawing the UML yourself, no, it will hit you. It takes time to understand a completely new design pattern, and you are learning so many design patterns together, right? But you should be able to understand that what are we trying to do? We are trying to have different behaviors. Commands are what? Basically, they are behaviors. So that is why this is a behavioral design pattern. Before this, we were like, other than observer, all the design patterns that we have done were creational. We were creating objects. Now we are not creating anything. We are checking the behavior of a particular request, right? How is it behaving, right? So let me just run this. Let me see, where am I? Okay. So I'm just going to run it quickly. So you can see simple. Whatever was happening, I don't care. Like in my main, I said menu dot click open, document saved. Actually, who is doing it? This document open, document saved. Where is it getting called? It is getting called in the receiver. And yes, all the code is already uploaded. So you can actually check it out. The only place where the output is there, it is in the receiver in the document. Yes. Let's look at the C++ code also. Then I'll show you another example. So here also, basically, this is the interface. Why interface? Because pure virtual function. Then there is document. This is the receiver who is actually performing the action, the document open and the document save. What are the concrete commands? The document, the action open. In the action open, there is execute. So what is it doing? It is telling the receiver that now you're supposed to do this. Similarly, concrete command action save, it is telling the receiver that now you're supposed to save. Okay. Menu options is the invoker. It has commands, as you can see. So this is the base command type. But see, again, invoker doesn't know that what command you have sent me. Invoker has no idea, right? Because it has base command. Who is setting the receiver and everything? Client is saying that this is the receiver. I want to do it on doc, or I want to do it on photo or graphical, whatever. Right? I want to do it there. So this doesn't know who is the receiver. Where are we doing it? Right? So again, very extendable. Let's see one more example. There's another example of Uber that I have given. So for example, there are different commands that come in Uber, right? There is a ride request command. There is a cancel ride command. So suppose I want to keep all this request. I want to log it that these commands came. So I want to store the command somewhere and say, this command came, then this command came, then this command came. So let's look let's look at the code. So this is the write service. Write service is basically the class that is actually going to perform that I'm requesting the write or I'm canceling the write. So this is what? This is receiver. This makes sense? Does this make sense? Yes? Okay, so this is my receiver. This is my abstract command interface. Execute is there, right? Execute is there. Again, pure virtual function. So all the concrete commands have to have execute. So you can see over here, there's an execute. And this is what? This is the receiver, right? So this is the receiver. I have named it also as receiver. It's a write service receiver. So you can see that receiver is the one who is going to request the write. Correct? There is cancel write command also. Again, concrete command. Again, receiver is the one who is canceling the write. Then write request invoker. So this is the one that is just going to process the request. What is happening over here? Firstly, I created a receiver. I created an invoker. These are the commands that I want to run. So basically all I said that write request the write from here. Keerti is requesting from Sarjapur to Kurumangala. Amit is requesting from Kurumangala to Indranagar. Right? So how is it getting done? Is the invoker is saying process request. Invoker is the one who is saying process request. And inside invoker, what is happening? Command is saying that execute. And inside command, what is happening? Receiver is saying execute, is saying request write or cancel write. Let's run this also and see. I am running C++ code now. So here you can see what were the three requests. Process request 1, 2, 3, right? One was request, second was request, third was cancel. So requesting a write, canceling a write. Where is it actually happening? It is happening in the write service, in the receiver. Can you please show the code flow again? I will do that. Let's look at the Java part also. So the Uber part, let's look at this. Everyone, full attention over here. Okay, full attention. Let's look at the main. What all things we need to do? Firstly, there is an invoker who is going to say process the request. What is the request? The request is basically a command. It says that command can be of different types, right? It can be a write request command. It can be a cancel write command. In the end, it should be a command. Okay, so the type is command. But what is the exact concrete command? It can be a write request or a cancel write, right? So I am saying that this is my request. Okay. So basically, write service is the receiver. So this is the one who is going to actually perform. So suppose, for example, right now, I have different services. Suppose I have Ola ride service and I have Uber ride service, right? And I have combined both. So I can have something like this command is for this particular service. This command is for this particular service. So these are what? Receivers. So my Ola ride service will receive and actually perform this action, or my Uber ride service will actually receive it and perform the action. Yep. Yep. Okay. So this is basically my commands. So this is the ride service, right? And this is an invoker. So this is the invoker, this is the receiver, this is the one that is actually going to perform the action. This is the one that is actually going to perform the action. Let's look at this once more. So if you see, this is the ride service. Here we are actually performing. This is the interface command. This is the concrete command, ride request command. What are we doing in this? Basically, we are saying this is the receiver, and just tell that receiver is supposed to do all of this. Right? Similarly, there is concrete command 2 also. Let's look at the UML once more and let's discuss now. I'm going to stop sharing. Looking at the chat also, do you have any questions for now? You can refer to the code. Everything is uploaded on GitHub, by the way. So if you want to check parallelly, you can check over there also. Sharing my screen. You can see, right? Let's discuss once more. So what are the basic components and what are they doing? Let's discuss it once more. So first thing was your command interface, right? What it is doing, it just has an abstract method. And what is the abstract method? It is say execute. That you need to execute something. The second thing are concrete commands, right? What are they doing? They are basically binding. So some of you told me use the exact definition. So I'm telling you the definition. They are the one that creates a binding, between the action and receiver. So basically, they are telling the receiver that you need to perform this, and they have the action execute. So they have the execute, right? Because this is abstract method execute. So they have execute, but inside the execute, they are basically doing something like this. That receiver dot do something, take action, open or save. They are telling the receiver, they are creating the binding between the action and the receiver. They are telling the receiver that you need to do this. Yes? Make sense? So basically, third thing is the receiver. Third component is the receiver. What is it doing? It is actually performing the action, performs action. What is the fourth thing? The fourth thing is the invoker. It is actually invoking the entire thing. Invoking, ask command to carry out the request. Yes, correct. Let me just write it down. So invoker is asking the command to carry out the request. So invoker is going to ask command. Command is going to do what? It is going to go to receiver. Receiver is the one who is going to actually perform it. Yes. Now client is the one. Fifth guy is what? Client. Client is the one who is actually going to firstly create the concrete commands. It is going to create the concrete command and associate with a receiver. So you remember in the main, what was I doing? I was passing the document, right? I showed you that either I can pass the document or I can pass the photo or whatever. Yes? Okay, I am quickly letting you unmute yourself also. Guys, we have to cover 2 more design patterns. It's going to be a longer class. We're not going to stop at 11 today. It will probably go on till 11:30. Just letting you know. Any questions here? I am letting you unmute yourselves.
Yes, so Keerti, one question. So can't we do invoke thing inside the client?
Can't we do? Yes, I said no. I already answered that. See, your client can also be your invoker. Just like in Builder, your client can also be a director. It is fine, right? But I am telling you the different components. Basically, invoker is the one who, sometimes it can be written like this. That is why you need to understand the difference. Client can be the invoker.
Okay. So two doubts I had. So for example, in this, this is kind of, so receiver, can't we have a receiver interface and we have multiple children's implementing that
Yes, yes.
receiver?
So you can have, say, text document, and from text document there will be, say, like notepad, or there will be lucid chart, or there will be something like that, right? Wherever you want to do it. So yes, you can do like that also.
Okay, so for example, it open for a photo will be a different thing and open for a file would be a different thing.
Yep,
Right.
yep. So what you would do basically in the client, when you're creating the concrete command, in the receiver, you can pass. So remember in the main, it was written something like this. If you look at the code, it was like command, and in this you were passing receiver.
As a parameter.
Whatever you had to pass, right? So receiver is basically, you can say that what is the kind of receiver.
Okay, and the second thing was I saw that command is inside the invoker, right? Command is inside the invoker and receiver is inside the command.
Yes.
So why are we keeping the command inside the invoker directly? Can't we pass it as a parameter like we are doing it for a
You can. So the point is basically that the invoker should be able to carry it out, right? So if you want to pass it, you can pass it. Maybe you can like keep it inside it. There's no hard and fast rule like for that.
That will break the aggregation relationship, right?
Yeah. That is, see, again, what is the crux of the design pattern? That there is a command interface, there are concrete commands. Now, either you can have the receiver, you cannot have the receiver. You can implement the execute inside the concrete command only. You can have the invoker in the client. It also, your aggregation might not be needed. It is fine. What is the crux? That you are treating the command or the request as an object. Are you able to log the commands? Are you able to undo, redo? That is the main part.
Thanks.
So basically, client has a unidirectional association with an invoker. Then invoker will be calling your concrete command, which is again a unidirectional association, and your concrete commands or command interface has an aggregation relationship with the receiver. Is that right to say?
Yes.
Okay.
Keerti, can you repeat what problem this is trying to solve? Because means if we do not follow this command design pattern, then the exact code which we have written, how is it going to be? Can you just tell us the difference?
See, if you do not know command design pattern, supposedly you do not know, and I tell you to execute to have this, that you want to on the fly decide the shortcuts, how would you design it?
Directly, we would put that on the document. Let's say there's a document class. So inside that there's going to be save method and then open, etc.
So then, you are okay. Yeah. Now okay. So every time, basically, this was a receiver, right? So you're telling that on this doc, this is how you need to save, and how you need to save is also going to be different, right? So you have to again and again tell, versus here, what we are doing is the doc is doing the receiving, but my client should not know how it is doing, right? I'm decoupling it. My client doesn't know how you're saving it. Otherwise, you would actually do this in the main itself, right? That you would write doc.save, and you would know that exactly what it is saving, how is it saving.
Okay.
Right? Now you're decoupling the entire thing. All I know as a client that I have a menu option, I am pressing click. That's all I know. Or I have associated 10 shortcuts to this one particular thing. You need to do the same thing. Why, as a client, I need to know that what you are doing, how you are doing.
Okay.
So suppose right now, I have this on click. Okay, I have this on click. And from that, I was doing doc.save. Okay. Now I configure and I say, I don't want to do this on click. I want to do it on Control S. You would have to go on the client side only. You will make change that on click. Okay, now this is not going to work. You add this code over here. On click, you need to do something else. You need to do doc.open. You're making so many changes, right?
Okay.
Versus when you have commands, you can on the fly add commands, remove commands. You can support new things, new features in your text editor. And only when the client needs to know it, what is client saying, that you invoke it. This is my receiver. My receiver is this, basically the document. Here I want to do it.
So, Keerti, let's say now I wanted to interchange the functionalities of save and open. I want to configure it that way. Then in the code that you have shown, should I be writing in it in the execute implementation of
what
action?
What are you are trying to do undo or redo? No, sorry.
No.
What are you trying to
I am trying to give Control O as save and Control S as open. I'm trying to configure new options. So
Right,
in that
right.
particular case, the code which you have given in GitHub, what are the changes that I should be making there? Should I
basically my invoker will say that this is the command that you need to call, right? My
Okay.
invoker was earlier saying that on click, this is the command that I need to run, right?
Correct. Yeah.
That is all the change that I have to do. That because now there's a different command that is doing that, just call the other command instead of calling this command on click.
Okay, Keerti, if this the question is done, could I have also implemented this in C++ using a map of commands to function pointer or function object? Would it be essentially the same?
Commands to function pointers. Okay.
Yeah.
So
So
you are
open
just
will
using
be
a map.
having a, and it's a map. So
So basically, whenever you want to change a function like a pointer, you can, yes, you can keep it in a map, but then tell me how are you going to log it, that what was called, then what was called. Right now, what is going to happen is that this command, no, I can pass it also as a function because this is now an object. So I can log it also that, okay, this object was called, right? I am treating it as an entity. You can call a function pointer. The function will be called there. But
yeah.
suppose
So logging will also happen there.
so if you're okay, you might log at that time, but suppose you want to go through the history that what all commands were called. What are you going to do?
Right. Good point. Yeah. Thank you.
Yes. Okay.
Keerti, actually, if new feature has to be added, then in invoker as well, new method will be added, right?
So basically, if a new command has to be added, the first thing that you would have to do is firstly add this new command, implement it, and secondly, only in this menu option, like suppose yes, in invoker itself. So basically, you are going to have that on click. Just call this new command. That is basically you are changing the shortcut. That when you press this shortcut, this is the command that needs to be called.
Like if there is for document open save is already available commands, and if new command like redraw command is there, okay.
So I
if
can just add it over here. My invoker doesn't need to change until it is actually calling it. Is there a button? Have you added a new button? If I click on the button, then I would have to obviously associate it with the command, right? But you're supporting the new command. If you do not want to have it in your invoker, don't have it.
Okay, so if that feature has to be used, then in invoker that new command has to be, new function has to be added in invoker.
Yes, yes.
Okay.
Yep. Okay, guys, I will pick up more questions, but for now, can we look at the next design pattern because we have two more patterns to cover today. Can we do that?
Just one question. Where will we do the undo redo? Where will the commands be stored? In invoker layer?
So undo, redo, you can achieve by this. You can probably have it in stack, all your commands you're storing, and then you can store this. Like I have not told you the implementation of undo, redo. That was basically a use case why command design pattern will be useful. You can use a stack for undo, redo, and all of that.
Sure. So which layer will store that? Will the invoker do that? Or where we have to implement that?
So basically, you can have a list of commands stored somewhere, right? Okay, actually, there's one other design patterns which we are going to cover. You can actually, today itself, you can keep all the commands together in a collection. And then, suppose in a stack, suppose in another class. And if you want to do undo, redo, you can do from there that, okay, this command was called. Now I want to undo this particular command. Yep.
Okay. Thanks.
So
And the undo logic of a particular command will be in the concrete command class itself.
That depends on how you want to do it. Essentially, you do not need to keep it in command. Like according to me, for having solid principles, you can keep only execute in the command, and whatever was the state before that, like there can be probably different class for managing the state, like different class who is keeping all the commands, according to me. After we cover the last design pattern today, this point will become clearer. Just give me some time. Okay. Shobit is asking, are we following OCP in Invoker in the case new commands are getting added? Yes, we are, because we are able to add the new command without making any change in the previous code, without any making change in the previous commands or the interface command, right? Whatever new command we add, we can just add execute into it. Okay, guys, I'm going to mute yourself now. Mute you all now. I am sorry for that. Let's do the other two design patterns also, and then we will come back to this and I will take more questions. Okay, somewhat have you guys understood? Can I get yeses, or still there is a lot of confusion? If there's confusion, I will repeat it again. I will. But have you understood? Honest yes. I can see some yeses. Can I get more yes? Somewhat yes. I really suggest that please over the weekend, go through the code, try making the UML yourself. Okay. I got a lot of yeses, so I am moving ahead now. Completely new case, trying to solve completely new problem. Lavish is saying, understood it clearly. It is now in my blood. Very good, Lavish. Okay, awesome. New case, new design pattern. Everyone, full focus over here. Have a sip of water, relax. Now, consider this case. We are all working in a company, okay? And suppose I am the one who did some expenses, like I took a cab, and I said that my company should reimburse it, okay? Now, because my cab is, say, the rent is, say, 500, the fare was 500, so my manager itself can approve it, okay? Approved very nicely. Now, suppose I'm working in a very good company. I have another expense, which is, say, medical expense. Okay. Now my medical expense is, say, greater than 5,000. So my manager cannot approve it. Okay. So it sends to, say, HR. Now my HR can approve it. Now there's another, after cab, there's medical expenses. There's another one that I want to take a course, which is very expensive. It is 1 lakh a course. Or I want to, like, for some degree or something. Okay. Even HR cannot do it. Someone like, senior position guy, senior engineering head, or someone has to do this, right? So basically what I want is, I want to create a system where I know that based on this check, so there are multiple layers, right? So I was the employee. After that, there was my manager. After that, there was HR. After that, there was, say, CTO. Okay. So now what I said was that based on the fare the employee sent to manager, the manager could either approve it or could send to HR, or it knows, suppose that it is too huge, can send it to CTO. So basically my manager is the one who's going to decide that who is the next person who is supposed to take this up. It might be HR, it might be HR, or it might be the manager that is able to solve the problem, or it might be that I have to send it to CTO. So basically on the fly, I am deciding runtime, who is the next person who is going to handle my request. Understood the problem? Understood the problem? That I want to on the runtime decide that who is the next person who is going to solve this problem. Okay, let's take one more example. For example, an error came in production. Error came in production. There were a lot of teams involved. There was team 1, there was team 2, there was team 3, team 4, and so on. Okay. So error came, team 1 said, I will just run my test and see. If my tests I have succeeded, what am I going to do? I'm going to just pass it to team 2. Succeeded, I'm going to pass it to team 3. Succeeded, pass it to team 4. Succeeded, I need to do some other kind of testing also. Versus, if team 1 passed the test, I come here, my test failed. Now team 2 needs to take some action, says that I'm going to make some change. When the team 2 says that, okay, I am ready, might say that I am going to take another action. When it is ready, I can either start again the testing from team 1, or I can say, no, I am sure this part is working. I am going to send to team 3. So you see, again, on the fly, based on a situation, I'm deciding whether the next person who's going to be testing, is it team 1 or is it team 3? It is somewhat like escalation, as I can see Karan is saying. So you understand the point that at every point, I am making the decision on runtime that who is the next successor, or handler who is going to handle this particular request or solve this particular request. Make sense? It's like Jira tracker. Yes. Let's take one more last example. In Swiggy, Amazon, whatever, Myntra, Uber, Ola, wherever, you make the payment. Payment succeeds, you go ahead and you place the order. Or suppose you take it out for delivery in your system, you start doing that. Payment fails, you say you're going to retry. And if it fails again, suppose you're going to go to notification manager and say that you need to notify that it has failed. So this payment gateway or the payment class is responsible that next I am going to either place the order, or I am going to go to my notification manager. On the fly, runtime, I want to decide that who is the next successor or handler. Everyone understood the problem that we are trying to solve? Yes or no? Yes? Guys, if I see only 1 or 2 yes, no, I will not be able to understand how many of you are awake. Just type one Y and send. That is also enough. S, Y, anything will work. Yes? Thank you. Cool. Okay. So what are the common things that we have seen so far? First thing is that there are multiple objects that can handle the situation, can handle a request. Who are the multiple objects that can handle a request? Like, for example, it was, say, employee, it was manager, HR, or CTO. Multiple objects that can handle the request. Or say team 1, team 2, team 3, team 4. Multiple objects that can handle the request. Or the payment, or like, order 1 or notification manager. Multiple objects that can handle the request. Tahira is asking me to repeat the Swiggy example, so I'm going to do that. In Swiggy or Amazon, I'm saying that I try to do the payment. If my payment succeeded, I am going to say, go to my delivery partner or place the order, or tell my restaurant that you have an order now, or go to like my inventory, Amazon inventory, and say that block this inventory, something like that, right? So if the payment is successful, I'm going to go ahead. If the payment is not successful, I probably need to go to notification manager instead of going to the restaurant or the inventory or whatever. So on the runtime, on the basis of that, was the payment successful or not, I'm deciding whether I want to go here or here. Yes? Okay. Rohit, Love, please try to, stick to the discussion that we are having, because others will also get, distracted, and I will also get distracted seeing sandwich and all of this. Yes, please try to stick. You can chit chat on Discord, but please, because while I am teaching, I'm looking at the chat for doubts, right? So it can distract me if I start reading these random comments. Okay. Based on state changes on runtime, next invoker is decided. Exactly. The next successor or handler is decided. So these, every object who is going to handle a particular request is called a handler. It is called a handler. So we are seeing that who will be our successor handler. So the main point is that handler is decided at runtime. This is very important. Okay. So request is not handled by all the handlers. Maybe it is handled by one. Even if it is handled by no one, it is fine. And if you see, again, we are trying to have loose coupling. See, if you notice, everywhere we are following solid principles. Okay. We saw in observer design pattern, there was loose coupling between what? Subjects and observers. We saw in command design pattern, there was loose coupling between what? Sender and receiver. Here is loose coupling between what? Between whoever is actually sending the request and the handlers. So I do not know, as a client, when I'm triggering this request, I have no idea which handler is going to do it. It can be like object 1, object 2, object 3, object 4. Is manager going to approve it? Is HR going to approve it? Is CTO going to approve it? I have no idea of it. As a user, what I want to do, I want to just upload my expenses and make sure that it gets approved. I don't care if my manager is approving it, HR is approving it, CTO is approving it. As a system, where I want to see that where the bug happened, I'm just going to say that the bug happened. Is team 1 handling it, team 2 handling it, team 3 handling it? I have no idea where it is going to be handled. I have no idea that who is actually going to take care of it. Right? So again, we are decoupling what? Request sender and the receiver. So there are multiple objects and we are determining at runtime. So there are candidates for handlers. Candidates. Candidates means what? They are the possible people who are going to handle this particular situation for us. Yes. And beforehand, I do not know that who are going to be my particular handlers. Make sense? So if we look at the UML, it is going to look something like this. So basically there is a handler, right? In my handler, again, there can be different kinds of handlers, right? So I am going to have, say, concrete handler. So concrete handler 1, concrete handler 2, okay? And there is basically a handle request that they need to take care of. Okay, so they need to have this handle request. They are implementing this concrete handler, right? My client is the one who's going to call the method. Now this handler, every handler is going to have a successor. So who is going to know that who is the next person that I'm going to send this? Only that particular handler will know that who is my successor. Only a handler will come to know who is my successor. Yep. Can I show you the code and then we can see? Can we look at the code? Yes. Can you all see the screen? Can you all see the screen? Okay, yes, cool. Let's go to what change did I do over here? Yeah. Okay, so command is done. We are in which design pattern? Chain of responsibility design pattern. And why chain of responsibility? So there's a chain being formed that which handler is going to handle this. Handler 1, handler 2, handler 3, handler 4, like that, right? So this is the Swiggy order wala example that we have taken. Let's look at the Java code first. So there is an order handler, right? There is an order handler. This is the abstract class. Why abstract class? It has a process order. Now all the concrete handlers have to have process order. Who are the concrete handlers? Let's look at it. See, first thing that we do is order validation. After order validation, what am I doing? Payment processing. After doing payment processing, I'm doing order preparation. After that, I'm doing delivery assignment. After that, I'm doing order tracking. Now, each of these handlers, only they know who is the next handler. If you see inside this, only they know that who is the next handler. Why is it protected? Because our derived class should be able to understand that who is the next handler, right? All the derived class is going to know. Yes, it is sort of like blockchain, right? So next handler we are going to come to know. When we create a handler, we are going to say, this is your next handler right now in the code. Okay. And every handler is going to have a process order. So if you go inside this, while creating order validation, I have sent this. And process order is doing what? It is just validating the order. And then it is calling the next order, process order. Over here also you can see that if the next handler is there, I'm just calling the next handler. Here, what am I doing? I'm just processing. Here, what am I doing? I'm just doing the preparing. And if there's a next handler, I'm calling the next handler. Okay. Again, over here, I am doing the delivery, assigning the delivery for order. And if it is there, I'm calling the next process order. Similarly, for order tracking, I am tracking. And if it is there, I'm performing like I am. Okay. Next handler is not there inside this, I think. Next, I should put a check that if next handler is not there, I should put this check. It is not going to be there inside this, and I'm going to pass. Over here, let's see. Okay, let's see how is the code being called. So this you can see, this is the order processing chain, right? So it's a chain. You can see the chain. How are we forming the chain? Order processing chain. For order validation, I am saying the next one is payment processing. For payment processing, what is the next one? Order preparation. For order preparation, what is the next one? Delivery assignment. For delivery assignment, what is the next one? Order tracking. After order tracking, there is no handler. I'm passing null. So a chain of responsibilities that my order validation is saying that the next person responsible will be the payment processing handler. The next person responsible will be the order preparation handler. The next one will be delivery assignment handler. After that, it will be order tracking handler. But client has to know the change, right? Yes. So either we can do like this, or there are more ways to go to write the code. I'm going to show this. Let's look at the CPP code first, and then I will show you what are the different ways of writing the code. Over here also, this is the order handler. Here you can see next handler, right? Order validation, payment processing, order preparation, delivery assignment, order tracking. Now over here, this is the chain code that we saw, right? In C++, who will tell me what problem I'm going to have if I write code like this? In C++, what problem am I going to have if I write code like this? C++ people, tell me. What problem will I face if I write the code like this? Yes, very good. Memory management. Okay. So so basically, why memory management? Because I'm doing new, right? So in this order processing chain, I'm saying new order validation. In order validation, I'm saying new payment processor like this. So where will I delete all of this? This is the problem. We don't have to handle all of this in Java, right? So another way of writing the code, or you can use the smart pointers also, by the way, or you can do it like this. That order tracking handler, I'm sending null. But for delivery assignment, this is the next guy. For order preparation, this is the next guy. For processing, this is the next handler. For this one, this is the next handler. This is one way of writing the code. So in this, we can delete all of it. Now listen very carefully, extremely carefully, the next part that I'm going to talk about. Either I can do this, or what I can do is I can have a function inside this saying set successor. So the question that you guys are asking, no, that my client has to know the chain, not necessary. I'm just going to create all the handlers like this. I'm going to create all of them like this. And in every handler, what am I going to do? In this handler, I'm going to have another function. Not over here. I'm going to add another function, set successor. I've written the chain to show you that it will look like a chain. It will look like a chain. But if you want to decide on the fly that who is actually my next successor, you can do that, right? How can you do that? In your assignment operator, in your handler, just do this. Don't pass anything, right? And then then based on some things, you can set your successor. Make sense? Guys, can I get yes or no? Why no? Why no? What if some class fails? Where would the notify or retry one fit? So if you want to retry, you can set yourself as the successor. If the payment processing has to be done again, if it failed, you can set yourself as the successor, right? So when I'm saying set successor, what am I saying? Set the next handler. You can set it to yourself. Yes? Or you can set it to the next person who you want to handle it. Team 1 can decide that my next successor is going to be team 2 or team 3. I wanted to show you why is it called chain of responsibility, because it can look like a chain like this. Like in Java also, it can look like this. So let's actually run the code and see once. This is which design pattern? Chain of responsibility, Java. So here you see, what did I do? I just did this, and then I said order is my pizza. I just told the order processing chain that you need to process the order. See, I just told the chain. I just told the chain that you need to process the order. Now it has validated, it has processed, it has prepared, it has assigned the delivery partner, it has tracked. I did not do anything. I just made a chain in the starting that these are the steps that need to be followed. And I said that the chain, come on, start processing the order. As a client, I do not need to worry how each of the handler is doing what. How are we validating the order? How are we processing it? How are we preparing it? How are we assigning the delivery? I do not care. Why? What do I care of? That I have made a chain. I have told you that you do this, then you do this, then you do this, and you do this. And then I am telling the chain that get started. And once I say get started, You want to handle the situations in a different way, do it. You want to set the successor, do it. Not my problem. I am the client. I just wanted to process the order. Make sense? Is the code part clear? Should I stop sharing, or do you want to see any part of the code? Can you please repeat about successor? Okay, I'm just quickly repeating it. See, basically over here, if you look at this code, with every handler, I am telling that who is the next processor, right? Here in every order handler, I am saying my next handler is this guy. So I'm predefining it. That order handler for my order validation, my next handler will be who? For my payment processor, who will be the next handler? That is what I am doing essentially over here. No. So if you see like this, just forget all of this. This is what I'm doing now. That payment processing is my next handler. Right? This is what I'm doing. For this one, this is the next handler. Similarly, if you see it like this, for payment processing, who is the next handler? Order preparation. For order preparation, who is the next handler? Delivery assignment. For delivery assignment, who is the next handler? Order tracking. So right now, the code that I have written is that I am passing the handler beforehand. But you remember all the examples that we saw. We want to decide that who is the next handler runtime. So in that case, what I can do is I can have a setter inside this. No, that set handler. And here I can pass this. I can just have another function like this, that public set handler. And now whatever handler was passed, instead of that, I'm going to say set like this. Does it make sense? So I am going to set handler on the fly, right? Based on some set, yes. So based on random setting, based on some particular examples that I have done. Do we have to prepare the chain in advance? That's exactly what I've been telling, that you can choose to not do that. You can choose to write code like this. I have commented it out and I've written like this, right? So this is one way of writing the code. The other way is you just do all of this. Don't pass anything in the constructor. There is going to be nothing in the constructor. This is how you're doing. Order tracking handler, delivery assignment, order operation, order preparation, payment processing, order validation. Now what I can do is delivery assignment handler dot set successor or set next handler, order preparation handler, set next handler. I can either do that or in the execute part itself, in the process part itself, process or execute, whatever you want to call it. Here you can say that if next handler, instead of that, you can say that set next handler to this particular processor, to this particular handler. Yes, but I should have access to the next handler. No. So that is why, to make it easy for you to be able to understand, I've written like this to show you the chain of responsibility. Yes. I'm going to stop sharing. I am going to enable questions for 5 minutes and then we'll start with the next one. Give me 1 sec. Yeah, any questions?
Yeah. So
how do we handle like if suppose if any handler is failing, that part like how do we like revert back to the payment? Like suppose after the payment there is an order. If suppose like there's some failure in order, then we want to go back. Like how?
Either you can do retry. In that case, you yourself will become your successor, or your successor will change. That okay. Suppose there's a notification. There are two handlers. One is error handler. Suppose, right? So if they did not work out properly, you will set your successor to be error handler or notification handler. That now notification handler will send the notification that something went wrong.
Okay.
If I make my own object as a successor, won't it be a recursive?
Yes, but if you can have like number of retries, or you can have like, okay, now I want to stop. Now this is my next handler. So the point is that you are deciding runtime how you want to do it. But you can obviously there are ways to handle this. The point is that, see, you are decoupling what that I just said, that process. How you're processing earlier, I can either tell the chain beforehand, or on the fly, you can decide that this is going to be my successor.
Okay, got it.
Yep.
So
In
basically,
the
we have
handler
to,
execute method, we need to before calling the next handler, we need to set the next handler, right?
Yes.
The
Yes.
handler
See,
so
it is
that it
not
will
necessary that
decide
you will
which.
always need the next handler. If there is
Yes.
no next handler, or if you have like team 1 has only solved it and says that team 2, 3, 4, 5 don't need to test it also, I've done the entire thing, you stop it. You have fulfilled the request, right? Sometimes there might be cases that none of the handlers are getting called, or only 1 or 2 handlers are getting called, and there were say 10 of them. It is not necessary that all the handlers will be called all the time. So the major points over here is that we are enhancing what? We are enhancing the flexibility of object assigned duties, right? So we can manage the chain on runtime. Yes?
Hi, Keerti.
Yeah.
So can we, like, instead of defining this in the client chain of responsibility, can we, do it in the each individual concrete classes? So let's say if you start the order,
I
and then
literally showed you the code also right now. No, I said you can have the set successor. That's what I
I
was
see.
showing. No? I was showing
Okay.
that set successor, you can have set next handler. I was just
Okay.
showing you the code, right? So instead of having the chain, you can do that.
But again, with the problem with that is, let's say if our process changed tomorrow, then we have to make changes in those like concrete classes, right?
Yes, yes. So that you have to handle. So that is why you have to see what works better. You either decide the chain of responsibility beforehand, or if you want to decide who is going to be the next handler runtime, right? So
And I think it's also possible to do it in a configuration file or something, right? That basically we can
yes,
just
yes,
refer to. Okay.
yes. The chain of responsibility that we were forming, like right now we were just passing no new. Maybe we can keep it in a list and we can keep creating like new and send it, right? There are multiple ways. What is the crux that we are handling next handlers?
Okay, got it. Thank you.
Keerti, can we also
And-
argue that if the client needs to prepare the chain beforehand, then it will be a very tightly coupled system, because the client has to know, right, what will be the next handler.
Tightly coupled, like with the client, you can say that, but see, still the point is ki, the client, like when I say press, like only while creating the chain of responsibility, the client knows. But when I'm actually executing it, right, just process, I do not know what is happening. Or maybe you can divide those two responsibilities also. Like maybe creating a chain of responsibility can be some other class's role, right? And on the client side, all you're doing is just process. So that is one way of decoupling it even further. That someone else will form the chain of responsibility. And right now in my client, in my main itself, I formed the chain of responsibility and I said processing chain dot process this request, correct? Now what you can do is that chain of responsibility, someone else will form. I will just process the request. So if you want to decouple it further, you can do like that also.
Hello, Keerti. Yeah, actually, here we form a chain. Actually, if there are multiple hierarchy in the chain, like as you mentioned, if there is a success or if there is a failure, so this is not a straight chain, right? So it is dividing somewhere. So in this case, there are two handlers required: one for error case, one for success case. So how to
See, your next handler, you have it, right? Now, if I have a setter, set next handler. On the fly, you can just change it, no? That this is the handler who is going to be called.
So there itself, we need to create the concrete instance of that.
No, concrete instance is there. But next handler has what? Process request function method, right? So you have, say, both the handlers, but which one are you calling? See, every handler has a process request, correct?
Yeah.
So now, which handler's process request are you going to call? Like, for example, let me share my screen again. 1 second. Like, for example, here in this handler, you can see, right? Hello?
Yeah, I can see.
So here you can see that in every order handler, there's a process handler, process order. Over here also it is, right? So probably I can have, say, 2 next handlers over here. And if the process succeeded, I'm going to say, success handler, success next handler dot process order, or I can say error next handler process order.
Okay, got it.
right? But you have to obviously invoke it, no? Or if you want to say that I am done, like I do not want to call any next handler, you can just skip this part. You will not call the next handler.
So in that case, this constructor will not require any parameter next handler, is it?
So you can, yes. So that's what I was showing you over here, right? So you can have it without anything. We want to set successors later.
So that will be runtime decided here.
Yeah. Yeah. So here I wrote, so I've written code in 3 ways, proper way. One is the order chain. One is that I am passing the next handler over here, right? This is one way. This is one way, creating the chain. The second way is that I'm sending the next handler. The third way is what? The third way is that I'm setting the successor.
Yeah, here the setting successor will be done in the process. Yeah. Okay.
Or you can set it like set say successor and exception successor, something like that. Get my point? That like if you want multiple next successors like that.
But that will be then again it will be restrict. No, so if there are multiple.
So I'm just telling you different ways of doing it.
Okay.
So as per the codes, I have 2 questions. So if we are keeping it at the interface level, that next successor. So for the handlers, right, which don't need any successor, that case would be a null case, right? In that case.
Yes. So here you can actually see it. So here order validation. So if you see over here in the chain, the last one that I am passing is null.
Okay. And the second thing is either we keep this next handler at the interface level, or we can have the set successor methods at the concrete levels, right?
Yes, but it is better to have it in the interface level so that all the handlers are forced to have a next handler, right? Like you should have a next handler, even if it is null. You're supposed to know whether you're supposed to end the chain over there or not.
Okay. Isn't it like we are forcing the children to have it, even though they have it as a null value then also?
See, if you are sure that there are going to be like, firstly, if you're putting it in a chain, then the entire purpose is that you're supposed to have a next handler, right? Right now, it might be null and it will be null only for the last guy, right? But if you're forming a chain, it like there's a high chance that either it will be a success or an error, and you need to take some action. If you need to stop, you need to stop there. But if you do not want that, it is okay. You can have process like in the concrete and not have over there. Next.
Okay. Yeah.
Hi, Keerti.
Hi.
Yeah. If we want to implement a state machine, so if we are going back to again suppose we have the states idle to means available, idle, running, stop, and again it go to our again idle. So in that scenario, how means round robin that thing, how we can implement that one?
I did not understand. You have some states and
suppose I'm implementing a state machine. So it is having some ideal state, available state, running state, and executing state, stop state. From stop to again, it should go to ideal state. So in that case, so our handlers means the last part. So if it is not going to null, so based upon the state machine handlers, how can we
so you're saying it is a cyclic, like from
cyclic, yes.
Cyclic. Okay, so you need to stop somewhere. So usually you need to make sure that your chain is not cyclic, right? So otherwise you will get into like an infinite loop. So probably you can have that if it is set, if the last one, like for example, in our case, this is the last one, right? Delivery order tracking. So if I have it as null, what am I going to do? Just set the null, but do not start processing it. Like set the state, but do not process it in my next handler. Right? So you have set it to ideal state, but if it is a state machine, obviously whenever whoever is going to trigger it, whenever you're going to start processing, it should be able to change it. In the last one, I'm just going to change the state. I'm not going to trigger the next process. Triggering only like client or someone else will do that. Okay, now you need to start triggering and start the changing states now. Make sense? This is a good point that you should never be in a cycle.
But in real systems, so we have to implement in such a way that so when the process is started, we have to execute again and again. Based upon the requirements.
If you want to do it again and again, then you want an infinite loop, no? Can do this.
Like some condition can be added, and based on that, it can be terminated.
Yes.
Yes, some termination condition has to be there. Otherwise, you keep going only.
That's what I was saying. For termination condition, you can either have like, okay, now it is the last one. I will just set the state. I will not call the next process one. So I am terminating over there. Someone is asking to give idea about state pattern. I wanted to today, but we really do not have the time. I will try to include it in next week. Or
One quick question, right here. Since handler is something that we're using everywhere, why don't we combine this with singleton pattern and make handler static?
Singleton.
Yeah.
So you want only one instance.
Yeah, exactly. So basically, I want my next handler or current handler, whatever I want to call that, to be static, right? Then all that context of setting the next handler, the responsibility of setting the next handler will go to the concrete classes.
So you can have singleton order validation that, okay, only this one wants to take care of this, only this one wants to take care of this. But still you will have the process order and the next handler, right? So
yeah.
Singleton is why singleton is creational. Here, what are you doing? Here you are talking about the behavior, that after this, what is going to happen? After this, what is going to happen?
Mm-hmm.
So singleton is about what? How are you creating this validation handler or this processing handler? Do you want one instance to be created? Singleton is about creation. Here we are talking about behavior.
So anyways, right? The next handler only, I mean, all the functions where we are assigning next handler, that is basically creating a new instance of next handler only, right? It's creation only.
Oh, okay. So here you are creating over here. You are not necessarily creating on the runtime, right? Like you can create earlier, right? So you could create, you can make all of these singleton. That is true. But you need to know who is my next handler. Like which function, like which object's process order needs to be called.
Right.
Okay, on similar line, can we say it is kind of builder only? In builder, only thing is we are building and there's a director who is deciding in which order we are building. Here we are, one handler is delegating to another handler.
Yes, you could say that. But
builder is like builder is for the creation, right?
That's
for different configs, how we're creating.
So
Here
that's
we
what he said. That is for creation, this is for behavior, but sort of similar thing. Like for creation, we had like a chain we had formed, right? That this, that was building. Here we are adding different behaviors, that this will be the next behavior, this will be the next behavior, this will be the next behavior. So you need to understand the differences between the design patterns.
But in builder, the steps are pre-decided. Here, steps are decided on runtime, no?
Here also you could do pre-deciding, right? Like chain of responsibility. Like over here, like I'm forming the chain, right? You could do both the ways. In the builder also, remember we talked at dot this, I can choose, I do not want this.
Yep.
Okay, guys, I'm going to pick up more questions at 11. Let's try to cover one more design pattern. Is that okay? More or less, I think you guys have understood. There might be small like implementation level details, but I think you guys have understood. Yep. Okay, quick revision. What did we do today? First design pattern was what? Okay, I'm going to take names now. Akshat or Madhumita, Rohit. Can one of you quickly unmute yourself and quickly tell me what was command design pattern? What does it do? Quickly, guys, we'll move on to the next one. Any one person just unmute yourself and tell me what was command design pattern. Hello. Tell me.
Yeah, so command design pattern is any system or any particular scenario where we are trying to encapsulate our commands or our request in a particular object. So that's the gist of it. And the most common example that you gave is just a document editor or anything like that. But other than that case as well, if in any place we see that we want to make changes to a system where we have delegate different tasks to different shortcuts or different particular, let's say, different assignments to different buttons or different actions, and we want to change them on the fly, then also this this design pattern is very useful, because we just need to change the allocated command for it.
Very good.
Yeah.
Thank you. And guys,
one question.
1 second. Guys, I can see some people have doubts about command design pattern. It might not have hit you in once. Just try drawing the UML and try every design pattern where you think you are not able to understand why. Okay, do this. Take the example that I told you, take the problem and see how you might have solved if you did not know that design pattern. Try seeing that how you would have solved and used solid principles, how you would have made it extendable, maintainable, how you would have followed OCP, SRP, LSP, ISP, DIP, all of that, how you would have done it. Okay. And you will realize that it is sort of a similar situation. Design patterns look complex, but they are making our life much easier because those are commonly occurring problems and we already have solutions to them. So it will hit you eventually. Just try drawing the UML, try understanding that what is this particular class doing, what is this particular class doing. And always, whenever you're not able to understand a design pattern, think of the problem that you're trying to solve. It will get clearer. Okay, someone was asking me something.
Yes. So in the calculator example that we discussed, suppose that we want to create a macro, which basically does a certain mathematical operation. So can command design pattern be used for that? Because we are encapsulating basic certain operations in an object.
Okay, what are the other commands that you have?
Like we have to create a macro, like a very simple thing, like what the calculator has to do, it has to perform 3 additions and 2 subtractions. This entire operation is a single operation and it has to be encapsulated. So is this a valid candidate for command design pattern?
Yes, yes, yes.
Yeah, it's a valid candidate.
Yep.
Macro is generally done by the command.
Yeah, thank you.
Okay. Okay, let's move to the next design pattern. Can I get some excitement in the chat? So this is the last design pattern of this week. Then we will move, then we'll be there next week. So last design pattern of the week, guys. Give me 1 second. Now you won't be able to unmute yourself. Sorry about that. Okay, cool. We will do a quick revision in the end also, so it is fine. And I know things get tougher and it is completely fine, but it will get to you eventually. Okay, it is cool, relax. Okay, next problem that we are trying to solve. Okay. So every data structure that we use, we have used a lot of data structures, right? We have used a lot of data structures, like we use arrays, we use vectors, we use list. Very nicely, we can go through the array or go through the vector, go through the list. In this vector, suppose if it is called V, I can do V for, suppose it is a list. Suppose it is a list. I can do, suppose the list is, I can do something like list dot first. What was the first thing, right? And list ka second. What is the second one? Or what is the next one? Next. Ka next. What is the next? Right? I can do all of these things and I can easily do what? I can easily iterate over the data structure. Correct? Now think of these cases. For example, you have a music system. You have a bunch of music right now. Okay. Now you have a bunch of songs and you can do next. Now there are different ways in which you might want to store these songs, right? Like one user might want to do next on the basis of, say, rating. Another person might want to do next on the basis of, say, singer or an album, or say on the basis of some other, like someone might want it alphabetical, right? So there are different parameters on which you might want to do next. Correct? Or for example, you have like a bunch of products, Swiggy, Zomato, Uber, not Uber, Swiggy, Zomato, Amazon. So you have a bunch of products there. Also, you can do next. But again, you can do on the basis of, say, rating, alphabetical. You can do on the basis of, say, popularity. You can say do on the basis of pricing and all of that, right? So you can do next on the basis of multiple things. Now, for example, you are very hi-fi engineer. Now you're getting good problems to solve. Okay. Now suppose one of the problems that you are trying to solve is, one of the problems that you are trying to solve is solved by trees. Now you have, say, a binary tree of objects. You have a binary tree of objects. Now there are different types of traversals, right? There is, suppose, pre-order, there is in order, there is post order. Now you just want to do next, and it should be able to go according to pre-order or in order or post order. Similarly, in a graph, suppose you can do traversal using BFS or DFS, but you do not want to see how it is being done. You just want to do next, right? The point is that how we are able to iterate through data structures. Now what might happen is that you have a collection of objects and you want to iterate through that. So how are you going to do this? Okay. And the entire point is that when what did I do? Sorry. And the point is that when I do the iteration, I don't want to know that exactly what you're doing. I just want next, or maybe there are other functions that I want, like previous, or maybe I want something else, right? Maybe I want next according to the according to the rating or according to the popularity, like based on different things. How you do it inside, I don't want to know. I do not want to know how you are going next. I just want to iterate. Understood the problem that we are trying to solve? Yes, no? Guys, this is a very common problem that you're going to have, right? That you will have a collection of objects. Now you want to iterate over them. And you do not want to again and again see if you are working on a collection of objects, you want this to be a last worry, that how the next is happening. You just want to say that I want the next. Plus what might happen is that right now maybe I am dealing with a collection of, say, orders. Now tomorrow maybe I have a collection of notifications. Now after that maybe I have a collection of something else. So basically you have different objects also. And on this object also, how are you doing the next? How are you doing the previous? That is also going to vary, right? So you want to make the iteration very generic. So what are you trying to do? You are trying to make the iteration as very, very generic. Make sense? The problem that we are trying to solve? Yes, no? I will need more yeses, guys, before I go ahead. Cool. Okay. Okay. So yes, like iterators from C++. So that is why, what is it called? It is called iterator design pattern. Iterator design pattern. Okay. So essentially what happens? Suppose we have to go over products. Now product. Now in product, there is a name. It's private. There is a price. There is, say, get name, get price. All of that is there. Get name, returns a string. Get price returns, say, double or float or whatever. And this is my class. Okay. Sorry for the very bad tappa. Okay. So this is my product right now. These are my members and these are my functions. Now I have an iterator. I have an iterator. In this iterator, I want first, which is going to obviously give me the product. I want what? I want the next one. So this is also going to give me the product. The other one that I can have is, does it have the next? To obviously iterate, I want to see, does it have the next? You remember in all the iterators we check, is end of the collection, is end of the list, right? Or null, is it null? I need to stop it somewhere. So I obviously have to have has next. Okay. So this is one iterator. Now I can have iterators for different kinds of objects, right? Like for now I want for a product, right? Like tomorrow I might want for a notification. I might want a notification iterator or an order iterator or a product iterator, correct? So what am I going to do? I am going to make this an interface. That every iterator that I have should have these three functions: first, next, and has next. So now what am I going to do? I'm going to have a concrete iterator, which I am going to call product iterator. And inside that, what am I going to have? I'm going to have a list of products. A list of products, right? So say it is private, list of products. And I am going to implement what? These three functions. First, next, and has next. Right? These three things. So this returns Boolean, these returns the product. So this is what? This is a product iterator, right? This is my interface iterator. This is my concrete iterator. And maybe like, what am I iterating over? Suppose you have an inventory. And this inventory actually had the list of products. And while creating this iterator, I have this iterator for this inventory. So while creating the iterator, I'm going to pass the list of products. So I have the list of products in this inventory. What am I doing? I'm creating an iterator. Okay, so I can create an iterator for this inventory. So creating the iterator. So this, the one who is going to actually create it is going to be called what? It is going to be called the aggregate. Aggregate means what? That it is the list. It is the actual collection, the inventory. It is the list of, it is the aggregate of products. This is called aggregate. Yes? Guys, make sense? More or less? Can we look at the code to understand properly? Yes? Cool. These ones are very easy, no? This and the last one were very easy. Not as hard as, say, builder or command and all of this. Plus, you get the flow, that the problems that you're trying to solve, right? Once you understand that, you will go like, yeah, it does make sense. I want an iterator, right? C++ code first time. Okay, cool. Okay, let's look at the C++ code for what? For what iterator? C++ Amazon inventory. Amazon inventory. Let's look at this. So there's a product. This is the product. It has name, price. Remember these getters, I made them as public. This is a constructor. These are the private members. Product is clear to everyone? Yes? I'm opening the chart. Okay. Product is clear. This is the iterator. This is the iterator interface. What are the three things that we have? Just remember, first, next, has next. See, for every design pattern, there are few things that you would need to like sort of know that, you know, these are the things that I should know. Like, for example, in observer design pattern, we had a collection. In the collection of observers, what did we do? Register and register notify. Here in the iterator, what are we doing? First, next, has next. These are the common functions that you need for any iterator, right? So all the concrete iterators will have to implement first, next, and has next. Yes? Till here, it is clear, right? There's a product, there's an iterator interface. Yes? Okay. Yeah, cool. So there is now a concrete iterator, and this is the inventor. Let's first talk about the inventory. Inventory is the aggregate class that stores the products and provides an iterator. So this is the aggregate where the products actually are. So you are iterating over what? You are iterating over the inventory, right? So we have a collection of products, exactly. So how you store the products? You can store it in vector, you can store it in list, you can store it in array, in whatever the hell you want. You can store it in map, I don't care. You will basically have a collection of products, that is inventory. Obviously in inventory, I can add a new product, I can remove a product, all of that is going to be there. But iterator is where iterator is for this inventory. So there's going to be a create iterator. Create iterator, and we are returning the iterator. So here what we'll be doing, we are passing the products. We are passing the collection, that iterator, be ready, and these are your products. So this is where I am creating the concrete iterator. Product iterator is what? A concrete iterator, right? What is happening inside the concrete iterator? In the constructor, I got the products. Okay, so I need to go over this. So I check what is the first one. To get the first one, I will set the current as 0, and I will return the first one. The products ka 0 I will return. In the next, I will just check if it has next. I'm going to like increment the value of current, and I'm going to pass the, and I'm going to return the products of current, right? The next one. Otherwise, I'm going to return null. As next, if the current value is less than products.size. Current is what? Current is basically a size. Like it is basically like, where are we right now? Are we on the first, second, third, fourth, fifth, like that, right? Yes, it is basically like a counter. So this is a vector of products that we are passing in the constructor. Let's run it and see. C++. C. So basically in the main, if you see what I did in the main part, what have I done? All I have done is this. Okay, let me run this again. Okay, so here you can see what am I doing? I am creating the 3 products. First thing that I've done is create the 3 products. Secondly, I created the inventory and added the products. This much is clear. No, I created the products, I added the inventory. Now I'm creating the iterator. I'm creating the iterator for what? I'm creating the iterator for inventory. The create iterator is where? Inside the inventory. Now I can get the product how? Iterator ka first, and I can iterate over it like this. So current product, iterator ka next. So what are we doing? We are iterating over a collection of objects, right? So whatever was my inventory, inside that I am saying create an iterator. So inventory is what? It is an aggregate, right? And over that I'm creating an iterator, and as you can see in the while loop, it went through all the products, right? So see out, whatever was the current product, I am just printing its name and price. Can you show has next code? Yes, I can show. So these are the 3 main functions. First, next, and has next. So in first, I am just returning products of 0. In next, I am incrementing current, and I am just returning the next one. And in has next, I'm just saying that current should be less than products size. That's it. Can't we pass iterator to inventory? Can't we pass iterator to inventory? You have to create the iterator for the inventory. You have to create the iterator for the inventory. You are iterating over the inventory only, no? So who should be the responsible for creating the iterator? That person itself, for which we want the iteration, right? Let's look at the Java code also. So this is the Java code. This is a product. There is name, there is price. Okay, in the product, there is name and price, like there are getters. In the iterator, there are 3 functions in the interface. These 3 functions are very important. First, next, and has next, right? Then there is product iterator. In the product iterator, there's a list of products, and then there's current. Current is what? Basically, I started from 0. So in my first one, you can see that I am doing current equal to 0 and returning current products ka 0. In the next one, I am just doing plus and then current. I'm passing the next one. And I'm putting the check that if there is a next one only, then I'm going to do it. Current should be less than products for size minus 1. Right? Inventory is what? Inventory is the aggregate. It is the list of products. Right? Vasant is saying, since we are using vector, we can as well use the iterators provided by the language. Exactly, Vasant. This is a very simple case. You can use this, right? That is why I gave you a bunch of examples in the starting. I gave you the bunch of examples. Why? See, right now in your next, in this function, what you're doing is just doing this. Now in this next, you could have alphabetically, you could have according to the rating, you could have according to something based on some parameters. So your client will probably will just say, I want next according to the rating, or next according to the popularity, alphabetically next. You will have those different kinds of next. How you do it, how you sort it inside, and how you give it to me, it is your headache now. I am just saying next. And today I am doing next over inventory, which is of products. Tomorrow I might want to do over notifications. I might want to go over my orders, or I might want to go over something else. It is any object I should be able to iterate over, even if it is a tree, even if the collection is a tree. As a client, I do not need to know how you are doing the next. Yes. See, when we demo something, even when we do it for builder, at that time, it seems like it is so easy, right? So for an iterator, because we're using a vector, for example, it is going to look like we are just using a vector. We are just doing next. But when you think about the actual cases, you might be dealing with so many objects, right? There are different kinds of objects. There's inventory, there's orders, there's notification. There is, say, Uber rides. There is, say, Zerodha stock. Suppose you are going through the entire stocks and you're going through the stocks in Zerodha, and suppose you want to go according to the highest market value presently or the most popular one presently. You want to iterate over the collection of stocks, but then you want to do it in different ways. So you want to have different kind of iterators, or one iterator, and you want to have different kinds of next, that next alphabetically, next popularity, next this. Yep. Why do we need first? Why can't we use next alone? Again, guys, get the crux of the design pattern. As I am saying, that you need to have an iterator, you need to have concrete iterators. That's all is the crux, right? If you want to have first, if you want to, you might not want to have first, you might want to have previous, you might want to have 5 next functions like this, that next according to popularity, or next alphabetically. You can have 10 types of next, right? But something that is usable for different objects. You can, you can either do it in your concrete iterator. In product iterator, suppose you want to have different kind of next, or you want to put it in your interface iterator, you can do over here also. But you get the point. What is the crux? You have an iterator, you have a concrete iterator. Okay, stopping the sharing now and giving you the access to unmute yourself so that you can ask me questions. Yep, tell me.
Okay, so we are creating the iterator classes, right? So I mean, can't it be like in the product class only we can have its next functions, or like you said, we want to fetch the stocks on the basis of market value. These things can be done on the DB level only, right? Or not on DB level, something like a store.
So you're saying in the product I should keep it?
Yeah, product. Yeah.
Okay, one sec. So there's a collection of products, right? So suppose there is stock 1, stock 2, stock 3, stock 4. So you're saying stock 1 should be able to sort. How will that happen?
No. So for example, first let's say discuss the MySQL database case, right? If we want to fetch it like in a sorted way directly, we can query it, right? Accordingly.
So database is what? It is a collection?
Yeah, database is, let's say,
a collection. So it corresponds to your inventory, right? The inventory that I created. Yeah. Your database collection is going to have an iterator, only then you're going to go through it, right? That is what we also have. An inventory has an iterator.
Could you repeat that once?
So, okay. So you are saying your DB will have an iterator, correct?
No. What I'm saying is, why is the need of this iterator? Can't we just directly do it from the DB side? Or in the product class only we can implement that one specific function, because the product class will be having a similar product.
1 second. Not everything you're going to store in your DB. Like some things you might want to, like, then why are you storing data structures in your code at all? Why are you having collection of objects? Right now I'm dealing with objects. I am not dealing with database. And then though we will keep everything in the DB only, no? Then why are we storing anything in memory, or why are we having objects?
Okay, so for like in-memory kinds of things, in-memory storage.
So you have objects and you want to iterate over the in-memory objects only, no? Like you have some data in your, like supposed to do some processing. Like for example, you have, you want to get the average of the 10 most popular stocks right now. Okay. So even if you took out of the DB, are you going to do the processing in the DB? Maybe you have the 10 popular stocks, you have the objects of that. You're going to do the processing, no, over that 10 objects. So you're going to iterate over the collection, right?
Okay. And the second thing is, let's say we are having products, and products can be of different types. So why not have a iterator function inside the product classes only, rather than
again I am just think about it. Iterate. Okay, let me share my screen again. You are saying iterate within the product, right? How will that happen? See, product belongs to a particular, say, stock 1. Stock 1, or say your DB ka 1 row is one product. That is one product. How will I sort it with other 10 products?
Yeah, okay, got it. So iterator is collections of products. So okay.
Yes. So you need to, so collection of products is what? It is inventory. And we are creating the iterator for inventory only.
Okay, so the things we do at the DB level, we are doing it here for the code which is not, which for the collection, for the data which is not there in the DB.
You can take it like that. Basically, you have some objects like classes ka objects, and you want to iterate over the objects. That is the use case.
Okay, got it.
Yeah, how do we inject this attribute on which you will sort it into the iterators actually? Because anyway, you need to sort it, right? Before you give the.
So how you are doing it will be whose headache? It will be the concrete iterator or the iterator's headache, the concrete iterator's headache. That how you do the next, or how you sort it, or how you want to do it. As a client, I won't want to know. So that is what I am decoupling it. What am I decoupling over here? I do not want to know how you are giving me the next one.
But you have to inject those attributes inside your iterator for you to really do the business logic to sort it, right?
So no, iterator is over some products. So it has the list, right?
Yeah.
So I've given you the list, but how you do it is not my problem.
No, understood. Like, say for example, let's say for example, you first do the sorting based on the number of rating, and let's say user takes an action to do it based on the price. Okay. Then the whole collection has to be resorted, which means that this iterator has to know that now I need to sort this collection based on the price before I give the next. Which means that this product iterator.
I understand. See, now how you are doing an iterator depends on you. Suppose in this iterator, I know that you are asking me again and again that next alphabetically, next according to rating and all. Maybe I'm storing it in 5 ways. Or like it is your implementation, or you want to sort it again, you can sort it again inside. The point is, see,
the answer should be like this. So right now what you have is the product iterator, right? The concrete iterator. So we can have more iterator implementing, like suppose we want alphabetical iterator. So you will have another class calling itself as alphabetical iterator, which will have that logic. Suppose now you want a rating based iterator. So you have another rating based iterator class which will have that logic. Now as a client, you will just say create rating based iterator. So that iterator, and then you do a next on that.
But that beats the whole purpose, isn't it? Because on the client side, you need to keep on calling different iterators. But
yeah, so as a client, you should know what kind of iterator do you need. You want a rating based?
Right? I mean, client just does an action saying that, okay, sorted based.
No. If you see the code right now, he's trying to create an iterator. Inventory dot create iterator. Even in the normal standard C++, if you see, there will be a different kinds of iterator for all vectors or list. It will be a backward iterator or const iterator or forward iterator. So as a client, you should know what kind of iterator do you need.
See, but the aggregator, whatever we are talking about as inventory, it is already holding the list, right? It's just sorting within that is what is changing. Somehow you need to communicate to the iterator saying that based on what I need to sort, isn't it, at runtime? I mean, maybe I might be wrong here, but
actually,
then
what I think is
basically
not to do sorting, because we are then violating the single responsibility principle. The expectation is whenever iterator will get the list, already some of the operations might have already been applied over it. Now, on that applied list, we are running the iterate. So if user wants to sort it, he will do the sorting first, and then you then pass that list in that iterator, and then they will iterate over it. It's not the job of iterator to do the sorting while doing the next. This is what I believe.
See the one second. See, the thing is like this, you can have your factory also, like client can only tell no that I want to create this, and if else and client, we can put in client only. The point is we want to decouple as much as possible. Our client should not need to know how you are iterating. I'm just saying you need to create an iterator. This is my inventory. And maybe there are different kinds of iterators, or there are different kinds of next, right? There are different ways of going about it. Like you want to create a different iterator, say for alphabetically or for rating wise or for this, you can create different iterators. But how the iterator is doing it inside, is it sorting or how is it doing? I do not need to know. You are decoupling it, or you are encapsulating the process and you are letting the iterator take care of it. You are not taking care of it. And if it is for different objects tomorrow, like for example, that same iterator, like right now I'm creating for inventory. So if you are saying that I could have sorted over here, I could have taken care of over here itself, but I would have to test, is it working properly or not, right? Now, because I know I've created an iterator, I don't have to test that is working properly because there's an iterator who's taking care of that. Now, if I, like today I'm doing over inventory, tomorrow I want to do over something else, day after tomorrow I want to do something else. Like I know that my iterator is working fine. I don't need to worry about it. Make sense?
Okay. Yeah.
But sorting logic, Keerti, you cannot put inside the iterator.
It will be inside the iterator.
You can't put it inside the iterator, right? So single responsibility principle, as per your doubt, right? It says that a class should do whatever it's told to do, right? The work of iterator is to give you the next thing, next object, next component, whatever you want, right? So doesn't matter how it is computing the next thing. What matters is that the responsibility it holds is to provide you with the next thing. It's not
So
Yeah, but if
yeah,
that is
well,
the case,
so
for all the
well,
types, this code will remain the same, isn't it?
No,
Yeah. So it's the thing is,
suppose
to
it
do
will
the
not
next,
be.
Guys,
do
one
the
by
next, there has to be some algorithm, right? And it's the iterator which will take care of what algorithm has to be run to do next. That is the crux.
So will each iterator have a copy of the products collection?
Yes, you need to have the products, right? Only then you would be able to do. No, that's why in construction
No,
we do pass.
Keerti.
Yeah.
Keerti, actually the crux of this pattern is whatever different kind of iterator you need, you just implement a next class from the interface iterator. And then whatever you want to do in that, you do it, like do a next algorithm.
Yeah, yeah. But her question was that will we need to pass the products? Yes, we'll have to pass it. No?
Yeah,
So
product has to be
even if
passed
we
in each
have
iterator.
different iterator for different strategies, each iterator will have one copy of the products.
Yes,
in
yes, it will have, yes.
I mean, I might be biased to the Java side, but let's say there's a very generic type of list of T, okay, then the entire code will remain same for any kind of collection, isn't it?
Entire code will remain same for any kind of
Any
collection.
kind of, let's say you're putting
What
list
if
of
it is a
products.
binary tree? What if it is a graph and you want to do next on the basis of, say, in order, pre-order, post-order? Do you want to have all of that in your client? Right now we're dealing with very simple vector list, but the code can be complex, right? You might want to iterate over a complex data structure.
Yeah, I mean, that depends on your parent type of what T is. Let's say it's a list
That
based
depends
one.
on your inventory, right? Like on your products. So the point is you need to be able to iterate properly. I'm not saying it will always be a list. I'm saying it can be a tree, it can be a graph.
Yeah, understood. It's
Yeah.
just that, let's say the parent type is list, tree, or map. For each of it, you got a different iterator. Rest remains the same, right? I mean, maybe the implementation of how to check the next and how to check the previous or the last for the tree and the map might be different. But for each parent type, there is only one iterator that you really need, right? Because there is not much that changes.
So that is why there is one iterator interface, and then you can create different iterators. Like you can have a product iterator and something other iterator, and then how you iterate over it is going to vary.
Actually, I think if you don't have your specific implementation, we can go with the data structures that are provided by Java itself, like array list or hash map, etc.
Like that, so we can create in client itself. Why do we need factory? Like that, so like, you know, we can also execute the command over there itself. Why are we creating a command separately? Why are we telling, okay, receiver? See,
no, Keerti, actually this, for example, if you take array list itself, it is implementing the iterable interface, right? So what I'm trying to say is already it is an implementation of iterator design pattern itself.
Yes, yes,
So,
yes, that is true.
Yeah, so it is taking care of, I mean, collection and even iteration or iterable interface. So both these things combined together all these data structures have been formed, whether it is array list or hash map, etc. Right? So if we want to go with a direct implementation, no specific implementation according to our project, then we can use these available data structures. Only when we have our specific need, we need to come up with our own implementation, I think.
Correct.
Yep, correct.
Yeah. Yeah, and also I think that the way we need it, because when we have different custom objects, so how do we are going to iterate over that? Let's say if we are searching, implementing the search or filter, then we need a certain specific parameters to do that. And then we can't just handle a complex object like that, using a for loop or while loop. So it's better to have your own interface that would provide you the API to move next and forward to do that. So that would be the best use case for that.
Yep.
Yes.
More or less, I guess you guys have understood. Yeah. Any other questions that anyone has? I can see so many people left very nicely. Yeah.
Yeah, I do. So basically, the first pattern that we were discussing, right? Our receiver is an interface, and I mean, you didn't create a receiver to be an interface, and then we had to decide what type of response are we giving to the receiver, right? So we had to pass what type of receiver we want in the class itself. Why not make receiver an interface?
Can do. Someone actually said that, and I said, yeah, can do.
Yeah, okay. And then the difference between chain of responsibility and command pattern, right? I mean, isn't it entirely same? In invoker being the, what do we call that? Sorry. Invoker being your wait, what?
See.
Director.
Yeah, no, the handler in the chain of responsibility pattern.
See, in chain of responsibility, you're telling who is the next successor, next handler, right? And what you're doing in command, you're saying that I've received an action and my receiver will take care of it.
So basically, chain of responsibility, the client or your wait, sorry. I mean, your client is telling who is the next handler, right? So you have that new, right? And that is what invoker is doing on the other hand in command pattern. It's
That
the
is what
exactly same thing.
Invoker is doing in command pattern.
Yeah.
Invoker is doing in command pattern. What is it doing? It is saying that you need to run this command and this is the right.
And then
but in that there is not a series of handlers, and it is not like there are possible candidates who can solve this for us. There is only one receiver who's going to solve it. In chain of responsibility, what is there? There are candidates of objects. Anyone could be solving them.
I mean,
Right?
isn't it same? Like if we implement the notepad example using command pattern, it would be the same.
See,
So
the purpose of the design pattern is what? The crux is what? What problem are you trying to solve? In chain of responsibility, what are you trying to solve? That I want to see that after this, who's going to take care of this request? After this, who's going to take care of the request? In command, what am I doing? My main thing is that I'm going to treat the request as an object. And someone else will fulfill it. Like my sender is someone else, my receiver is someone else. I'm making my command as a request, like my command or request is an object. Here, it is not the objective is not that. My objective is that I'm processing, but who is going to process that next? Only that guy will decide that, okay, now I have processed it. I will now decide who will process it next. That is the crux of it.
Yep. Also, I mean, one more question, right? It's more related to the real world case scenarios that we have. Both command pattern and chain of responsibility patterns, right? Do we actually use them? Because as soon as we started discussing them, I was straight away thinking of pub/sub models and message queues, right? Since I
So
mean,
like observer also, I was covering this while talking about observer, right? Because observer is essentially pub/sub in high level system design. But when you talk about high level system design, you talk about microservices and high level things, right? Over here, we are talking about, say, 5-6 classes as a compact module. You can think of it like that, right? So if you're dealing with the classes within that, how are you going to take care of these things? That is why, if you noticed in Observer, I gave you examples of traffic light and all of that, where you might not have different microservices. You will have different classes, and then you have to do that, right? You have to subject and observer is going to say, going to register.
Yeah.
Similarly, when you're dealing with small objects, how are you going to handle such situations? Like in data structures, we know how to iterate, but how to iterate over objects, that is what we are trying to talk about.
Okay. Sorry, I was not there in the last class, so I might have missed this.
Oh, okay. Oh, watch the last class. It was very good, very important also.
Yeah, I'll do that. Some person emergency. One more question I have from the previous class. If no one has any doubt, I can go ahead with that. It's more related to the UML diagram. But yeah, I'll stop and you can.
So can you give an example of how the chain of this thing, right?
Chain of responsibility.
Responsibilities design pattern, how it is working in the runtime, because as per the code, it was not in runtime, right? We are designing it at the client level only.
And that is why I showed the set successor part, right? So you
can choose the successor in the function itself, right? Based on some parameter.
Right?
No. You are not. Let's say you have, let's say based on that particular payment address that Keerti mentioned, you either have payment failed once, then you are going to retry. You have payment failed twice, then you are going to go to the notification manager, right? You can put that logic. So you have two different ways. Like either you can recall that payment function, or either you can go to the notification manager. You need to have all the like possible options with you. Yeah, that's like a must. But which option it will follow, that is being decided in the runtime, right? By the if else or whatever logic you have written inside the payment function itself.
Yeah, got it. Thanks. Yeah. And one more thing. So these are the basic methods which you told, right? So now let's say I have to design a rollback also. So then we have to know about the previous handler as well, right?
Yeah. So yes, so these are the basic ones that are expected to be there in Iterator design pattern. You can obviously customize, add more functionalities.
Thanks.
Keerti, I have a question. In the Iterator design pattern, what is the purpose of interface? Like I can understand we have an interface and we are trying to make things generic, but what other kind, what other concrete class can we create, and how can we use both in the same scenario? I'm not able to clearly get.
For example, right now we have one simple next iterator, right? For as others were saying, we can have an alphabetical iterator. We can have a rating iterator. We can have a popularity iterator. So now in the iterator, when we do next, the implementation of the next is going to be different, right? So there is an interface. These are concrete iterators. The implementation of next is going to be different in concrete iterators. And what are the concrete iterators? Alphabetical, popular, rating, according to that.
Okay.
Makes sense?
Sure. Actually, I was thinking there will be a product iterator, and we can give an argument like whether it should be based on popularity or.
Better is to create a different iterator itself.
Yeah, sure. And for the previous question, runtime, the chain of commands pattern, right? So we'll have
chain of responsibility.
Sorry, chain of responsibilities. So we in a case where when there is a success, something should happen, failure, something should happen. In that case, we'll have two handlers, and based on what happens, we'll call the appropriate handler, right? So again, that is not runtime. We'll store both the handlers, and we can call the handle case alone, right?
See, the thing is,
it's more than runtime. It's like we are giving this freedom to the client to decide the responsibility what next is going to be. So as a library, we are giving it to the client. Okay, you can set the next to this successor. After this happen, you are set to this.
So as someone explained that it has some choices, and it on the basis of some logic it decides the handlers, right? So we can also add multiple handlers, right? Success like the ahead ones.
Yep. So basically on some logic, you want to decide who will be the next handler. So you're keeping it extendable in that sense.
Okay.
In that case, might have a list of successes as well, right? For example, if in the interface we had defined it as a let's say an object, right? It might change it to list of objects also, right? I mean list of handlers.
A list of handlers, yeah, could be that these are the possible handlers. Now you choose among them. Yeah, it could be like that.
I think it is
it could be a difficult situation if we choose list of handlers, because all for different handlers actually different kind of conditions can occur. So number of handlers, next handlers would be different for each handler case. So if we keep the list, it will be like it will be it will not suffice the purpose.
What purpose will it not suffice?
Means if suppose handler one, if we keep the list, okay, list of handlers, if we next handlers if we send, and there if there are multiple conditions, like three conditions can occur, okay, then there three next handlers are required. So for handler two, if there are two conditions only are coming into picture, so in that case two next handlers are required. So
See,
these
so you can decide either you can send a list, or maybe that handler itself can create the next handler. Like, there are a lot of ways of dealing with this, right? That is not the crux of the design pattern that we are talking about. The point is that we should be able to see that who
yeah,
is the next successor.
correct. Yeah. Keerti, actually, I am a bit interested. What is the thought process this Ganga 4 has been applied to create these design patterns now? If we think that way, then whenever we get any real problem, then currently what I'm feeling is we are by hurting these design patterns. So instead of that, if runtime, if we could think and create a solution. So
See, the thing is, you need to think that if you wanted to follow solid principles, how would you design it? Like, if you have a problem of iteration, you have to follow solid principles that, iterator need to have this. Like, obviously, you can keep thinking about it and you will come up with it. But then there's already a solution that you need to understand why is it like this, right? And now when we have the UML diagram, you should think, how is it following solid principles? How is it a good solution? Is there a better solution? All of these discussions are good, but then coming up with the design pattern, obviously the discussion is going to take a lot of time when there are so many design patterns to cover. Like, already we are not covering a lot of behavioral design patterns, right? So I obviously have to draw a line somewhere. If we start thinking from, like, how would you solve this problem? Like, if you think of singleton design pattern, what did we start from? That, okay, we want to have a single instance, right? And then we said, okay, now for that I need to make the constructor private. Now I said that, okay, now I need to make the instance as static. So we took it step by step. Similarly, for observer also, we said that, okay, there's a subject, we need multiple people to know, so there are observers, so we need a collection over here. So we did that. So if you think about it, we are actually talking about the thought process. It is not like I'm telling you do this, then do this, then do this, right? So, but you need to have that understanding that we did this, then why did we do this, then why did we create this class over here? Like, we talk about handlers. So here, why do we need a common interface? Because we will need the next successor as the same one, right? So we are having a handler inside the handler, that, okay, this is the next handler, this is the next handler, this is the next handler. If any of the design patterns, if it is not hitting you, let me know. I will cover it again and I will build the thought process for you. Which design pattern did you feel that we by-hearted it and we did not understand the thought process?
Probably one approach can also be that, let's say you have a problem, like any particular problem came to you. Instead of thinking which design pattern you are going to apply, just think about how to solve the problem. Don't think about design pattern at all. Just think how to solve the problem, and yeah, stick to solid principles. Then once you start to draw the different UML diagram and something, then slowly it will automatically click to you that, okay, maybe these two design patterns is very much matching with what my requirements are. And then from these two, probably you can further filter, okay, this is not missing there, this is present here. In that way, probably you can choose the best design pattern suitable for your case. But if you try to select it from the beginning, then you might get confused.
Right. Even in command, if you saw, we first saw that, okay, there is a menu option, we press. Okay, so now when we are pressing, there are different kinds of commands that need to be invoked. So there is an interface. All of them need to be executed. So there's an execute abstract method. But who is performing this? The receiver is performing this. So there's a receiver. So Vishwanath, if there is any particular one that you did not understand the thought process, let me know. I will help you out.
Okay, yeah. Basically, for command only, actually, I felt it more that it is, it's like I am biting, but yeah.
See, command, what is the problem that you're trying to solve? You want to store the requests. Okay, now if I give you this problem that I want you to log all the requests and I want you to do undo redo, how would you do it without the design pattern? Take this as a homework, try to solve it and let me know.
Fine.
Okay, it is okay if you're feeling that. It might be my mistake. Think about it. If you're still
No,
getting...
it's not like a mistake actually. What I'm wanted to convey is that if we try to bring that thought process while in the session, so it will help us like that.
Yep. That has been my intention so far. If it did not come, like if you're still not able to understand command design pattern, let me know. I will cover it again. And for any other design pattern also, if you're feeling like that I did not understand the thought process, let me know.
Sure. Thank you very much.
Yeah, actually, Keerti, for the command pattern, where we felt lost, I mean, at least from my side, is the example that you have started with to understand the problem is like a stack of options, like undoing and redoing in the document, right? But when we actually tried to solve it, we took a different example. So for me, I was not able to relate both of them. Like, how are we solving? So at least for command pattern, if we can solve this redoing and undoing, let's say the last 10 commands in a particular document, maybe for me that will help in understanding the pattern completely. Right now it is, I mean, I can't say like I understood it 100%. So yeah.
I will try to cover it, but also can you guys please take it as homework that try to do the undo redo yourself based on the command design pattern. Try to make the UML. And if still you are getting stuck, because see, even I took like weeks and months to understand these design patterns, right? So I am not expecting you to understand 100% right now, honestly. I'm expecting you to make the effort, try it out. And if you still have questions, ask on Discord. Like try to do undo redo, try to write the code and I will review it. I will check it out if you have any problem.
Sure. Okay.
Yeah. Thank you.
Yeah. One more question, right? So it's not from this class, it's from previous class, coming back to it. In builder pattern, we had a director and we had an interface into iBuilder and then the concrete classes. And we said that director has a concrete builder, right? But in the UML diagram, we showed the aggregation from director to the iBuilder.
Because which kind of builder it will be, we don't know, na? Like in that, the type is iBuilder, but what we are passing is the concrete builder.
Correct.
Right. So in that, it has a like iBuilder, like interface builder, but what we are passing is exactly concrete builder, right? So we can show from the iBuilder itself, right? Because obviously when you're passing the object, it is not going to be iBuilder.
Yeah, correct. Okay. I mean, I just wanted to say that we can do that, right?
Otherwise, you would have to show it from each of the concrete builders, no? Then it would be wrong because you won't be having all the 4 in that, right?
Yeah.
All the builders in that. So yes.
Makes sense. Okay, cool.
Any other questions?
Let's say in this command pattern, right? I mean, let's assume we are not aware of this pattern. The generic way or the crude way to do this is, let's say document.open and document.save, right? And additionally, the use case of you need to keep track of the actions we have done on this document type, meaning you need to track which has been done first and which has been done next. For you to undo and redo this operation based on the state at that particular step. You will just add the state along with the type into a list. So you know the track of which was done first and which was done last. And you just use the actual type, right?
What if I want to associate like the other example that I said, that right now I'm doing save from button. I also want to do from like 3 different ways, from 3 different shortcuts. Right now you were doing doc.save from this particular way. I want to associate from a different event, like on click. Or this is one use case that I'm giving you. Second use case is that I want to log all the requests that came. Now you said you will keep it in a list, but how will you keep it in a list? You will treat the request as an object only, right? Like to keep it in.
I'll treat the request an object, but the only thing what I felt it was too much of an overkill was you had 3 layers in it, right? One was the command, one was invoker, one was the actual client kind of thing.
See, if you think about it, you are also keeping the command, right? You are also keeping the request as the object. I am also doing that, correct? What invoker is just calling. You would have called from client. My client itself would have been invoker. So you also have invoker. It is just a fancy name given to it. Now you could either perform the operation doc.save in the command itself, or you could give the document to perform it. I give the document to perform it. And I was told also that you might not need receiver. You might want to you might want to do it in the concrete command itself. You and I are doing essentially the same thing, but I am actually telling you the like different ways of doing it. You are also keeping command as object. That is the crux of design pattern. That is what we have to do. Keep command as object. That is it.
But the selling point is to really do this main undo and redo operation, or it's just that the
not
concept
just undo and redo, not just undo and redo. Maybe you want to send this command as a parameter. Now you can send it as an object in the parameter of a function. You can store command as a data member in another class. Right? You can keep the collection of commands because now it is an object. That is what you would have, like, if you did not know about command design pattern, if I told you that I want like all the commands and you should be able to pass it somewhere, you would have made it an object yourself. Yes, that is what we are doing in command design pattern. But like I am telling you further ways of, decoupling it. Let receiver do the handle, whoever is calling it, call it invoker. That is basically the guidelines that are given by design pattern, and I need to cover that. But it is okay if you don't have a receiver. It is okay if you don't have an invoker. Whoever is calling the command is the invoker.
A good example of the same is Elasticsearch indexing, the code we write for Elasticsearch index or Elasticsearch store. Any user profile we do, we are essentially making that command an object so that we can log it in DB and then rerun if we want to check something, if it went wrong with any user profile. It could be used in any systems, for example, banking, ATS systems, user profile systems and Zomatos might also be using the same. So yeah, I mean, a lot of, if you say, for example, I mean, there are commands that do a lot more than just, opening and saving a document. For example, the entire index profile is a very big command, right? So therein these patterns might be useful.
Yep. Okay, guys, go sleep now. Whatever questions you have, I will be available on Discord all the 4 days. Let's meet on Tuesday. Yes, can you guys please start working on the hackathon? Take it seriously, practice over the weekend, draw the UML, ask me questions, bug me as much as possible on Discord.
So Keerti, quick question. So this hackathon is the project that we do as groups, the groups that you formed.
So
in the
I guess you joined a bit late, kya? In the starting, I said either the maximum number of people in a hackathon group can be 4, like 1 to 4 people. You can choose to do it with the people I assigned you in the group. But if they are not responding, if you don't feel connected to them, if you want to do with someone else, it's fine. You have the entire sheet over there. If someone else is very active, there's a place in the group, just join it and just do it. The point is that you should participate and work on the hackathon.
Okay, sounds good. Thank you.
Okay, chalo. Tanmay is asking, we just have to do LLD, like all the code in a single file, or incorporate some HLD also. No need to incorporate HLD, but it should be working LLD code. I should be able to see it, like it is library management. So I should be like probably, I will give you all the details. I will send it. I'll send you a mail now itself. Yeah, cool. Okay, see you guys. Good night. See you on Tuesday. Thank you for joining. Hope you had a good class. Thank you. Thank you for joining for 3 days.